Hi, welcome to another episode of Phil's Outdoor Hacks. So, how does any camping trip start, any picnic start, even if you're going to invite people out over to your house for dinner out in the backyard? How does it start? It always starts the same way. It starts with a cooler and food and ice. And a few hours later, what do you got? You got a cooler and ice and food and water. Yeah, I know you spent a gazillion dollars on a Yeti and the ice hasn't melted very much. It melts. And in a not very long, you got a mess because you had a bag of salami in a little Ziploc bag and you threw it in with the food and it leaked and water got into your salami and you were going to go camping for a few days and you put a container of eggs in the cooler and they were cardboard and the cardboard got all mushy or water got into it's a mess. It's a mess. We all know it's a mess. And what if you could go camping and not have that mess? Well, the obvious thing is you get those little blue canisters, little blue plastic things that they ship frozen food with. Yeah, they're fine. They break. They're expensive. But how about a better way? How about a way to keep all your food cold? I mean, really cold, because what happens if you go camping for a couple days and you put in a piece of frozen meat and 3 days later, it's sort of frozen, right? It's sort of frozen. It's frozen because ice is 32 degrees and the frozen meat in your refrigerator was 28 degrees, 27 degrees, 26 degrees. It came up to 32, it was sort of frozen. What if you can keep your meat frozen and keep everything cold and keep everything dry? That's what you want to do. That's what I'm going to show you. And the whole trick behind all of this is the simplest chemistry in the world. And that is that salt lowers the freezing point of water. So if you have one of these, this is a soda bottle. It has salt water and food coloring in it. That's all it is. And it's colder than ice. This one is about about 20 degrees. This is about 20 degrees, which is 12 degrees colder than freezing. What do you notice about it? You notice it has frost all over it. Why does it have frost all over it? Well, I took it out of the refrigerator about 5 or 10 minutes ago. It didn't have any frost on it. It was in the refrigerator. But sitting out here, the ambient humidity in the room, in my house, froze onto the bottle. When you put these super cold bottles in your cooler, the moisture, which everything that you put in your cooler is inevitably going to be damp or wet, all of that stuff that goes in there, the moisture that's going to form the humidity in your cooler is going to freeze onto the jar and onto your frozen soda bottle. And so not only are you going to keep everything cold, you're going to keep everything dry. It's like having a dehumidifier in your cooler, the exact opposite of having a whole bunch of ice. So, how are we going to do this and what are the ratios and all of that? Well, I'm going to show you. In order to lower the temperature down to 23 degrees, which is 23 degrees Fahrenheit, which is 9 degrees below freezing, which is minus 5 centigrade, you need about 80 grams of salt for 1 liter of water. 80 grams is 2 7/8 ounces. It's also just a little bit less than a third of a cup. So also when you make these little frozen bottles, you don't want to confuse them with anything else. I put a little red dye in them. You can put yellow dye or blue dye. I use red dye. It doesn't matter. The point is, I don't want to confuse my ice substitute for anything else. Okay, so all you do is, boy, this is so simple. You just pour your salt. Now you can use any kind of salt. There's no point in using expensive sea salt. Use the cheapest salt you could buy. I buy kosher salt because kosher salt is pure sodium chloride, NaCl. It doesn't have any minerals, doesn't have any iodine. It dissolves quickly. And I like that it dissolves quickly and I like that it's cheap. Okay, so what you do is you pour some salt in your water, you shake it up, you use warm water, it dissolves a little faster, doesn't matter. You wait till this dissolves, and then you fill it up this high. Notice there's about an inch between the top of the water and the lid. Just 2 drops, 2 or 3 drops. You don't need much. This stuff is very cheap. It's just, here's 3 drops. 2 drops are actually enough. You shake it up. There you go. You're not going to mistake that for anything else. Now here's what you do. You loosen the lid just a little bit. You squeeze the jar until just a little bit runs out. Now you got a mushy bottom. When water freezes, it expands. That's why ice floats. It expands, it's less dense. So if you were to fill this all the way up and freeze it, this thing would burst, just like the beer bottle that you forgot in your freezer last week. So because I leave a little expansion room by squeezing out the water, this is exactly how this was. I filled it the same way, but now you can see, if the camera shows it, this is frozen all the way to the top, but the bottle is not distended. Now, here's the critical piece that you need to know. I pulled this out of the freezer and I squish it, I can squish it, and I can feel that it's not fully frozen. It's almost frozen. Now, why does that matter? It matters because of something called phase change. Some of you know what phase change is, some doesn't. It's very simple. Phase change means going from solid to liquid. In the case of ice, when it's solid, the hydrogen bonds make the water molecules freeze into these cool hexagonal structures, which are really stable. To break them in that solid, to get that to liquid, you got to put in a lot of energy. That means it's hard to thaw. That means they stay cold in your freezer longer. If you get this bottle almost frozen, it's like slush or just a little past slush, it's not going to stay frozen very long because the warmth that's in the cooler, the air that's in the cooler, will be enough to turn that slush back into liquid. But if it were absolutely solid, it wouldn't. It would take more heat energy to thaw it. So you want to get these completely solid. You got to feel it. If you squish it and it has any give, leave it on the counter overnight, let it thaw out, pour off a little bit of the salt water, pour in a little more water, put the lid back in, squeeze it so it doesn't explode in your freezer, and freeze it again. And by trial and error that way, you'll have water that'll freeze solid but is still salty and freezing below the temperature of ice. So what do? I have a dozen of these. When I go camping, I take all dozen and I check into the campground and I go to the local store and I buy whatever I buy. I buy coffee, I buy milk, I buy beer, I buy bait. And I say to the guy, hey, I got 6 these little bottles. Can I throw them in your freezer? I'll pay you a couple of bucks. He says, no, almost inevitably. Almost always the guy will say, no, you just bought bait and beer. Just throw them in the freezer, it's fine. And so I throw them in the freezer. Next day I come back with my bottles that have begun to thaw. I throw those in his freezer. I take the ones that are now solid out of his freezer, I put them in my cooler. I always have a dry cooler. I always have super cold. It's always super cold. The meat that I put in there 4 days ago at home that was frozen solid, guess what? It's still frozen solid. That never happens when you go camping. I don't care if you have a Yeti. That never happens. This is how you do it. And what's so cool about this is that what does a soda bottle cost? How many of these do you throw away? Over the course of a lifetime, thousands. You just, it costs nothing. And salt costs almost nothing. Food coloring costs almost nothing. And so instead of spending $8, $9, $10 every few days when you go camping, or every time you invite people over for a picnic or whatever, you have essentially free ice. It'll save you a lot of money over a lot of years. If you do this, your food will stay fresher, cooler will stay dry, you won't have a mess, everything is easier. Happy camping.